Hello, my name is David Ackerman, student number 220310629, and this is the dynamics assignment number one, which is mandatory. So here we read the problem and we gather all the known values, and this is solving for part A. So first we draw the free body diagram where this is the elevator, there's the force of gravity of the elevator going down, there's the tension 1, 2, 3, 4, and then there's the force of the counterweight, which is listed right here. Now, these are the givens: the mass of the elevator, the mass of the counterweight, the speed of the elevator, the acceleration of the elevator, which is zero. So velocity, the acceleration is 0 meters per second, so the velocity is constant, and the motor efficiency, which is 0.6. So for part A, at the elevator, the force of the elevator equals mass of the elevator times the acceleration of the elevator, which the sum of the all forces, which is tension 4 plus tension 3 plus tension 2 plus tension 1, minus the force of gravity of the elevator, which is opposing the motion, which equals to the mass of the elevator times acceleration, which is zero. So we have all the tensions minus the force of gravity, which equals to 0 newtons, and we can see that tension 1 based on the diagram, tension 1 plus equals tension 2, which equals tension 3, which equals tension m. So tension 4 minus force of gravity of the counterweight equals 0. So tension 4 equals the force of the counterweight. So Tm equals force of gravity of the elevator minus force of gravity of counterweight divided by 3 because there is 3 tensions. And now we substitute in mg, mass of the elevator, minus mass times gravity minus mass of the counterweight times gravity. We factor out gravity, and then we sub in the known values: 9.81 for gravity, 400 kilograms for the mass of the elevator, and 60 kilograms for the mass of the counterweight. And we compute divided by 3, compute that, all of it, and we get this number right here. Now we get the power for the elevator, which is power equals force times velocity, which equals the Tm minus times v, which we're given that the velocity of the elevator equals 4 meters per second, meaning that again its acceleration is constant, which is 0, times the number that we're given, and then we compute that, and we get that the power equals 4.45 kilowatts, or 4,444.2 watts. Lastly, we calculate the efficiency of the in the calculations. Uh, so E equals efficiency out minus efficiency in. We rearrange it for E in, and we plug in all the known values for P power minus the efficiency. Then the energy in would be 7,412 or watts, or 7.412 kilowatts. And that is part A. Part B is that we're supposed to answer why the shortcomings of this plan, and here I am explaining it, that there is insufficient counterweight effectiveness. The counterweight is much lighter than the elevator and its contents 60 kilograms versus 400 kilograms. This leads to a significant net force requirement, to a powerful motor and a high efficiency consumption. The number two is energy and efficiency. With a motor efficiency of 60%, the 40% of the input energy is lost due to heat. This makes the system inefficient due to the high use because the elevator is being used a lot. Mechanical wear and tear, running the motor at a high power continuously during rush hours, which meaning that the rush hours that customers or personnel are using the operator a lot, can lead to overheating and faster wear of the components, increasing to m- maintenance costs and possible injuries. And space constraints. Adding a secondary elevator is solely for belongings might consume more space and increase cost, which could be avoided by optimizing the current elevator for or using alternative solutions listed any of the above. This is the first assignment mandatory. Thank you for watching.